One guess, right? He is right. Seriously, how did these guys? I missed the one lesson of doing this sometimes. I'm at a disadvantage. This is the one this is retained, never talk about it again.
Okay, guys, let's get started. So today there won't be too much of syllabus to cover. I think we just have 2 or 3 slides left from this learning unit, and then after that, I'll give you guys an ICE task to complete for the rest of the session. It's a bit of a long one, so we'll make it count as 2 ICE tasks.
Yeah.
Right? So yeah.
So pass to the board and like when we doing those who have done that.
You're assigned today for the ICE task. We can do that. We can do that, yeah. Okay. You make a reasonable suggestion, I can take it, no problem. All right. Okay, so guys, the last time we stopped before inverse image. This is the last thing we need to do with functions, and it's, I wouldn't say difficult, you just need to think a little bit for it. So I didn't want to do it late yesterday. So now while everybody is fresh, well, I don't know. Yeah. So either it's too late or it's too early. I have to catch you guys middle of the day to learn something. Okay. So anyway, it's not too much of stuff. So I'll start with an example as we usually do. So firstly, an inverse image. Firstly, we know what an image is. An image is just the output of a function. So again, I'll give you guys that same example we looked at the last time. If I had a function f of x is equal to 2x, and then I say for the input, x is equal to 1, output is f of, let me not say f of x, let me say f of 1. F of 1, let this thing work. F of 1 is equal to 2 times 1, which is 2. So in this example, as you guys may remember, the image is 2. The image of 1 is 2. Okay. And just one more to complete the thought. If the input is 2, the output here will be 4. So what's on the right is an image. What's on the left is the input. Right? So that's what we did yesterday. So now inverse image is just the opposite. If I give you the image, you have to go back to the input. It's just going the reverse direction. Right? That's all it is. So, yes. An inverse image is the input. The function is a different thing. But the function, the inverse function will give you an inverse image. Yeah.
Oh.
Okay. All right, so here we don't worry about deriving functions. Yes. Sorry, say again?
What is the purpose?
You mean in real life?
No, language was. I never noticed that. What is that?
I'm trying to think in terms of programming and stuff. So input output situations. If you're given the output, sometimes you might want to get back to the input. When though? That's a good question. Can you even think of an example of when that would be relevant? Because I can give you examples in like research and physics and stuff like that, things that I'm doing, but that's not going to affect you guys. It's not relevant to you guys. I'm sure there's a situation in programming somehow when you're given an output and you need to invert your program to get back to an input. I can't think of a specific example, but there must be something. All right, guys, let it stew. Let that thought stew for the lesson. If you think of anything, let me know. If I think of something, in fact, after I'm done with this, I'll look it up. I'll give you a better answer. Okay. All right. So anyway, inverse image is just the opposite of what we did on the board here, this example. Just taking the output, going back to the input, right? And it's easier than working out the actual inverse function. We don't have to do that here, okay, which is a useful thing. So the way we denote an inverse function is just the symbol up here with the f to the power -1. Right? You guys may have seen that in high school to represent an inverse function. It's kind of like, you think about it like this. An inverse function is something where you filter images through to get the inputs. All right, so just like before, maybe let's write something here. For an inverse function, f minus 1 of x, whatever that may be, you will filter outputs or images into this. So from this, you'll get f of x goes back to x, right? It goes in that direction. That's what the inverse function does. Again, all this abstract stuff is good, but when we look at a concrete example, you guys will see why I'm saying this stuff is straightforward. Okay, so let's do that because here we usually work with sets, which makes everything a whole lot easier. It's discrete. We can see all the elements. So let's look at an example before we get too lost in the abstract stuff. Yeah, sure. All right, so here we have an example. Remember, these are still always given to you in the same format that we've been looking at before, where you have f double dot some domain and some codomain. Right, and they've even given it to us in this weird compressed form at the bottom here. This compressed form at the bottom shows you the range at the bottom, right? The actual outputs. So the bottom here shows you the range. So we have all the information here. We have the domain, codomain, and range. Just to recap, the top here always gives you the domain first. Sorry, not the codomain. Domain, codomain. And because of this form at the bottom, we now have the range as well. So we have everything we need. Okay, so given something like this, the question says find the complete inverse image of each element in the codomain. Right, so that means we need to start at the codomain. Is here. Find the inverse image of each of these elements, right? And that we can do. Okay, so let's see, how will we state that? Let's see, let's write it like this. We'll say for the first one, f of minus 1 of the codomain here is, let me just think, do I put the element directly here into this because that x here takes elements from the domain. So I'm just trying to find the ideal way to write this. Okay, so let's just check how they do it because that's how we're going to have to write it to get full marks. So before I write something which may make sense but is not consistent, let me just jump quickly to the module manual, which I can't see here for some reason. There's it right here. Just to get their notation sorted out. Okay, so where are we here? Learning Unit 3. Okay, why there's so much of stuff here? What's this? Learning Unit 2. You know, let's just go to the contents page, make our lives easier. Learning Unit 3, we are at functions. Can I just jump straight to that? 284 doesn't work. Okay, I have to type it here, but then I have to bring a keyboard out. Oh gosh. Backspace 284. Is anything happening here? Why is it doing this to me? Okay, let's just scroll to 284. Not bad. 203, 240. We lost it. We almost there. Okay. Okay, this is the same example. How do they denote it? F of minus 1. Okay, so it is what I suspected, which is a bit weird. But anyway. All right, just need to double check that. Sorry, guys. Let's go back. So the inverse image of the first element in the codomain we write as f minus 1a. Okay. Now the output here must be everything that goes in from the domain to give us a. So we can read that straight from this matrix kind of diagram they gave us here. So can you guys see everything that had to go in to give us a? Right, it's just 1 and 2. Right, so that's the answer here, 1 and 2. Okay, so the question says to do this for each element of the codomain, so we can do that. That's not too difficult. And this is why you guys see why I said this is not really a difficult section once you get the hang of it. So for the next one, the next element of the codomain, again, following the codomain up here, A, B. B is the next one. So now what inputs do we need to get B? According to the matrix type of rule we have at the bottom, it says 3 filters in to give us B. So the answer here is just 3. Basically, it's like matching, just matching each input with an output. And you guys can tell me the last one. Is it the last one? No, it's not. F minus 1 of C. Can you guys see what goes in to give me a C? 4, 5, 6. Perfect, right? 4, 5, 6. So it looks like we're done because we exhausted all elements from the range, but there's still another element in the codomain, which is D. We haven't done that one yet. So the inverse image of D, does anything give us D according to our rule here?
No.
Doesn't look like, right? So then the answer will be the empty set. You can write it as open brackets, open and close brackets, or just a symbol for empty set. Either one is fine. Okay, any questions so far? Is the stuff mostly okay?
Yeah.
So now we'll do one more example, which is a little bit tricky. But again, it's the thing, once you see one of them, then you know how to do it. That, okay, you guys still writing here? All right. Is this the last one? Yes, it is. Okay. So we have an example here. We're given a function from integer to integer. So the codomain is integers, the domain also the integers, and the function is given in sort of a usual way that we're given functions. In terms of numbers, so g of n is equal to n squared plus 1. And we're asked to find the inverse image for these specific elements. Okay. That I'm sure we can do. So let's think about that for a second. Firstly, what's the domain and codomain here? It's just integers. So both are the same. So let's just write that somewhere. Domain equals codomain equals, I could just write Z here, but let's just fill in some numbers, -2, -1, 0, 1, 2, and so on. Or you could just say integers, whatever. That doesn't look good at all. Let's do that again. So Z. It's still not, anyways. Okay. So now what does it mean to find the inverse image of 1? It means we have to find the n that went in to give us this 1. Right? So that means how we would do this is we would say n squared plus 1, which is the function, must give us 1. And then you just solve for n.
Okay, I was not plus 1.
Because that's what the function is given. N squared plus, it goes into the next line for some reason. Yeah. Yeah, maybe let me just write that one time nicely. Gn is equal to n squared plus 1. All right, and I think we can solve for n here quite easily. So let's do that. This here is going to be n squared is equal to 0, or n is equal to 0. Or, okay, I don't know why I'm trying. Yeah, let me try not to take up too much space because we have more stuff to do. So n is equal to 0. So then how would we write the answer here? A set containing 0, right? That should be the thing. So the inverse image of 1 should be set with 0. And we can check if it makes sense. And so this is an input that gives me the output 1. So we can check if I put a 0 into the function, do I get 1? Yes, I do. And it works out. So the temptation here is to write this as the empty set, but that's not the same thing. Because the empty set contains nothing in it. This contains a 0. It's different. Okay, do you guys want to try the next 3 by yourselves? Or do you want me to do one more? Let's do one more, okay. Let's do g minus 1 of 2 is what they're asking for. So just like before, we just need to know what the input is that gives us the output 2. So the input is given by the function n squared plus 1, and we told that the output is 2. So it must equal to 2. So the pattern here is that we always just do that and equate it to our output, and then just solve for n. All right, so we can solve for n here. Let's do that. So we'll get here n squared is equal to 2 minus 1, which is 1. Or n is equal to technically plus minus 1 here. When you take the square root, you'll get a positive and a negative 1. All right, so that means, you see, this is why I don't like some parts of this module, because sometimes they tell us to ignore the plus minus, sometimes they tell us to consider it. So here we have to consider it, because the answer is going to be g minus 1 of 2 is equal to a set containing minus 1 and 1. Right, that means if I filter minus 1 into the function, the output is 2. Or if I filter 1 into the function, the output is still 2. And that makes sense because minus 1 squared, same thing. Okay, do you guys think that's enough information to try the last two? All right, let's see what happens. Let's make this all visible.
Oh, no.
Anybody got the same answer? Inverse of 3? Good, okay. Perfect. So I guess we get the hang of it now, but let's just do the last one for completion's sake. 10 n squared plus 1 equal to 10. N squared equals 9. N equals square root 9. 9 can be broken up into 3 times 6. Okay. What am I saying? Plus minus 3. So let's write it here. Hey, the last one we all okay with? I wish I could. It stops here. Okay. So if you look behind you, maybe you can see it there. Okay. You guys have a WhatsApp group for this class. Maybe if you guys can't see it, someone can just take a picture and share on the group for you guys. That's fine.
Yeah.
Okay. Yeah, just good. Just to celebrate the end of the learning. Okay, guys, any questions on anything before we start with an ice task? Maybe I should stop the recording now.
Nice.